Okay, slide number 14. Equilibrium in oligopolistic market. So Nash equilibrium. Nash equilibrium means a set of strategies or actions in which each firm does the best it can given its competitor's action. Right? So set of strategies where each firm does the best it can given its competitor's actions. Okay? We already studied Nash equilibrium in introductory level microeconomics. So Nash equilibrium is each firm is doing the best it can given what its competitors are doing. Okay? So anyway, we studied oligopoly, right? So simplistic version of oligopoly is duopoly. Duo means two, right? Only two firms exist. That is special type of oligopoly market, simplistic oligopoly market. That is duopoly, okay? Duopoly is the market in which two firms compete with each other. First, we studied the corner model. The corner model, oligopoly model in which firms produce a homogeneous good. Each firm treats the output of its competitors as fixed. Each firm treats the output of its competitors are fixed. And all firms decide simultaneously how much to produce. Right? So a quantity competition model. Corner model is a quantity competition model. So look at this. Figure 12.3 of slide number 15. Demand curve. Firm 1's profit maximizing output depends on how much it thinks that Firm 2 will produce. Right? If it thinks Firm 2 will produce nothing, Firm 2 produce nothing, its demand curve is like this. Right? Think about this. Firm 1 thinks Firm 2 produce nothing. Then Firm 1's demand curve is shaped like this. This one is like that is demand curve when Firm 2's production is equal to 0, right? Then marginal revenue is like this, right? And we also assume constant marginal cost. Marginal cost is like this. Okay, the profit maximizing condition said you produce Q where marginal cost equal to marginal revenue and charge this price. That is price, right? Also, only think about quantity. Then this company's production is this one. How many? 50, right? Q1 production is 50 under the assumption that Q2 produce nothing. Okay? And now think, now what is the next? Right? If Firm 1 thinks that Firm 2 will produce 50 units, then Firm 1's demand curve is like this. Firm 1's demand curve is, for example, like this. For example, that is demand curve when Firm 2 produces 50 units. Okay? Then marginal revenue is shaped like this, isn't it? That is marginal revenue when Firm 1 thinks Firm 2 produces 50. Then profit maximizing quantity is marginal revenue is equal to marginal cost when this company produces 25. Okay? And finally, if Firm 1 thinks that Firm 2 will produce 75, then we can draw this kind of, how can I say, this kind of demand curve. When Firm 1 thinks Firm 2 produce 75 units, then marginal revenue, right? Marginal revenue when Firm 1 thinks Firm 2 produce 75 is like this. That is 12.5 units. Profit maximizing is like this. So anyway, we know that production of Q1, right, under the assumption that Q2 produces something. Okay? That is, from here we can derive reaction curve, right? Relationship between the firm's profit maximizing output and the amount it thinks its competitor will produce. For example, write this, reaction curve, right? Y variable is Q1, X variable is Q2, right? Q1 thinks Q2 is equal to 0, then profit maximizing quantity should be equal to 50. Okay. Right? That is 50, for example. About 50, right? When firm 1 produce firm 2, firm 1 thinks firm 2 produce 0, then profit maximizing quantity of Q1 is 50. Okay? When firm 1 thinks firm 2 produce 50, firm 1 produce 50, firm 2 produce 50, then firm 1's profit maximizing quantity is 25, right? 25, right? And if firm 1 thinks firm 2 produce 75, then firm 1's production is 12.5. Okay, if we connect this kind of thing, we can get firm 1's reaction curve like this. This is a firm 1's reaction curve. We said Q1 star when Q2. Right? Q1 is function of Q2. Can you understand? That is reaction curve. Similarly, we can draw a firm 2's reaction curve. Right? Firm 2's profit maximizing quantity of firm 2 critically depends on the assumption, firm 2's assumption of Q1's production. Okay? That is shaped like this. That is, for example, shaped like this. That is firm 2's reaction curve. Q2 star, function of Q1. Right? That is figure 12.4 of slide number 16. Right? In Carnot equilibrium, each firm correctly assumes the amount that its competitor will produce and thereby maximizing its own profit. Therefore, neither firm will move from this equilibrium. So Carnot equilibrium is intersection of two reaction curve, right? Simultaneous solution of simultaneous equation consisting of two reaction curve, firm 1 and firm 2's reaction curve. That is Carnot equilibrium. Actually, this Carnot equilibrium is Nash equilibrium, right? So look at this again. Firm 1, for example, this unit is, I don't know the number, maybe that is, for example, 65, and that is, for example, 20. That means that is Carnot equilibrium, right? Firm 1 thinks firm 1's profit maximizing quantity is 20 under the assumption that Q2 produce 65. Okay? Also, firm 2's profit maximizing quantity is 65 under the assumption that Q1 produce 20. Okay? Then, no reason evade from this equilibrium. In that sense, Carnot equilibrium is Nash equilibrium. Each firm correctly assumes the amount that each competitor will produce and thereby maximize its own profit. Therefore, neither firm will move from this equilibrium. Okay? So, next slide. Carnot equilibrium. Equilibrium in the Carnot model in which each firm correctly assumes how much each competitor will produce and sets its own production level accordingly. That is Carnot equilibrium. Carnot equilibrium is an example of a Nash equilibrium, as I said before, and thus it is sometimes called Carnot-Nash equilibrium. In a Nash equilibrium, each firm is doing the best it can given what its competitors are doing. As a result, no firm would individually want to change its behavior. in the corner equilibrium, each firm is producing amount that maximizes profit given what its competitor is producing. Thus, neither would want to change its output level. Okay? So now think about numerical example. Anyway, so this chapter 12, special oligopoly case, so numerical solution of mathematical solution matter in the exam covering oligopoly. Okay? So you have to practice how to solve this kind of thing. So what is basic numerical example? Now, example, slide number 18, example, linear demand curve example. Two identical firms face market demand curve like this. Market demand curve is price is equal to 30 minus Q, right? Also, marginal cost of firm 1 to equal to marginal cost of firm 2 equal to 0. No marginal cost, for example, simply talking. Okay, constant and equal to 0. Then total revenue for two firms like this, right? Total revenue of firm 1 should be equal to other firm. Price multiplied by Q, right? Total revenue is price is equal to 30 minus Q multiplied by Q1, right? And that is marginal revenue, isn't it? I'm sorry, total revenue. And this Q consists of production by firm 1 and plus production by firm 2. So rewriting this, 30 minus Q1 minus Q2. In other words, Q is equal to Q1 plus Q2 because duopoly model, right? So multiplied by Q1, right? Then we can 30 Q1, expanding this one, 30 Q1 minus Q1 square minus Q1 Q2. That is revenue of firm 1. Marginal revenue of firm 1 is change in revenue, more accurately, this one, partial derivative of total revenue function with respect to Q1. Okay, partial derivative. Then first derivative of this one with respect to Q1, right? Then what is this? 30, only 30 left. Here, minus 2Q1. Okay? And Q2 is just constant numbers, so only Q2 left. That is marginal revenue of firm 1. Right? And we know marginal cost 1. This one should be equal to marginal cost 1. That is profit maximization condition, isn't it? Marginal revenue is equal to marginal cost. Okay? And earlier assumption that marginal cost of Q1 is equal to 0. This one is equal to 0. Right? Then we can, from here, we can derive reaction curve for Q1. Right? Rewriting this, 2Q1 is equal to 30 minus Q2, isn't it? Then Q1 star, Q2. Q1 star is equal to 15 over half Q2. Right? And also Q1 like this. That is reaction curve for Q1. Also, we can derive reaction curve for form 2 following same step. Right? So I'd like to use this one. R2 is equal to price. Price is 30 minus Q. Q equal Q1 plus Q2. So like this, multiplied by Q2. Right? Then marginal revenue in form 2 is partial derivative of this one. Right? This one is equal to 30 Q2 minus Q1 Q2 minus Q2 square, isn't it? So partial derivative of total revenue with respect to Q2 is equal to only 30 left. This one minus Q1, this one minus 2Q2. This one should be, that is marginal revenue, should be equal to marginal cost of form 2. Right? MC2 is equal to 0. So like this. From here, we know that Q2 is equal to 15 minus half Q1. Okay? So I'd like to go there again. Q1, reaction curve for Q1 is like this. Reaction curve for Q2 is equal to 15 minus half Q1. Right? So we can solve this one, these two simultaneous equations. Then we can calculate Q1 star and Q2 star, isn't it? Right? So how can you do that? So this one inserted here. Okay? Then Q1 is equal to 15 minus half. Q2 is equal to, instead of Q2, we insert this one. 15 minus half Q1. Right? Next step. For example, we multiply 4, right? By both sides multiplied by 4. Then 4Q1 is equal to 15 multiplied by 4 minus half multiplied by 4 means only 2 left, right? And 15 minus half Q1, right? In other words, 15, that is 60, minus 2 multiplied by 15, so 30, plus Q1 left only, right? So 4Q1 is equal to 60 minus 30, that is 30, isn't it? Right? Like this. Then, this one moving there, 3Q1 is equal to 30. Then Q1 star should be equal to 10. Right? So simultaneous equation of this one means Q1 star is equal to 10. Form 1 produce Q only 10 unit in this corner solution. Right? Q1 is 10, then Q1 is 10, then Q2 is also equal to 10, right? Half multiplied by 10 is 5. 15 minus 5 is 10. So Q1 star, Q2 star equal 10. Right? Then we can calculate the price. Price is equal to 30 minus Q, or 30 minus Q1 minus Q2, right? Then 30 minus Q1 minus Q2. Then that is also 10, right? Then P star is also 10. That is corner equilibrium, right? Then we can also calculate the profit of form 1 and form 2. Form 1's profit is pi 1 star, right? Price is 10. Q star is also 10, right? And marginal cost equal to 0 and constant, right? So no cost production function. Total cost equal to 0, right? Then profit should be equal to 100, right? So similarly, pi 1 star equal to pi 2 star is equal to 100. That is corner solution, first example. Got it? That is explained in slide number 18. Okay? Now we studied slide number 19. 19 said, what happens when two forms collude instead of this corner equilibrium, right? So summarizing, when this is the case, Cono equilibrium is this one, right? Cono equilibrium is this one. When this numerical example, that is Cono solution, right? Cono solution is Q1 star, Q2 star equal to price is equal to 10, and firm's profit is 100 respectively, right? Now think about collusive outcome of this case. Collusive outcome of this case. Collusive outcome. In this collusive two firms, if two firms collude, then in other words, two firms behave like monopolists and share total profit equally. Okay? That is collusive outcome. Then two firms total production, they maximize joint profit, for example, right? Joint profit is equal to price 30 minus Q is in, right? And multiplied by Q, right? Then total cost is equal to 0. So profit is like this. The first derivative of profit function with respect to Q. That means expanding this 30Q minus Q square. And marginal profit or marginal revenue is equal to only 30 left minus 2Q, right? This one is equal to 0, right? So in other words, Q star is equal to 15. 15 production shared by two firms. Q1 plus Q2 is 15. So Q1 star is equal to Q2 star is 15 over 2, 7.5, right? That is 7.5. That is collusive outcome, isn't it? Right? Then what happens in price? Price is equal to, if Q is, we know Q equal 15. So price is 30 minus 15. So price is 15. Right? So like this. When two firms behave like monopolists, right? Production amount lower than Cono solution, right? And charge higher price than Cono price. Also think about profit. Profit of two firms is equal to, profit of firm is, price is equal to 15, firm's production is 7.5. This one multiplied by this one. Then what happens? I cannot calculate. What is this? Maybe 225. So 225. So this one. Right? Right? This is a collusive outcome. That is studied in slide number 19. Okay? Also think about that is collusive outcome, right? That is collusive outcome. Okay? Now think about then what is competitive outcome? Competitive outcome, right? Competitive outcome, think about profit maximization condition for perfectly competitive market. The condition is price equal to marginal cost, isn't it? Right? Then price is equal to marginal cost. So 30 minus Q is equal to, marginal cost is equal to 0. Okay? So Q is 30. So Q1 star and Q2 star is 15. Right? When right? Then price is 30 minus 30. 30 minus 30 is 0. So price should be equal to 0, equal to marginal cost. Okay? So price is equal to 0. then profit is also equal to 0, isn't it? What is profit? Price multiplied by Q minus total cost equal to 0. So anyway, profit is equal to 0. So this one should be equal to 0. That is competitive outcome. Okay? Of this situation. Right? Okay, look at this. And now we go slide number 20. Right? The demand curve is price is equal to 30 minus Q, and both forms have 0 marginal cost. In Cono equilibrium, that is figure 12.5. In Cono equilibrium, each form produces 10. The collusion curve shows comparison of Q1 and Q2 that maximize total profit. If the firm collude and share profit equally, each will produce 7.5. Right? Also shown is the competitive equilibrium in which price equals marginal cost and profit is 0. Okay? Now think about figure 12.5. Write this. Right? That is Q2. That is Q1. Reaction curve for Q1, firm one's reaction curve, right? In Cono equilibrium, firm one's reaction curve shaped like this. That is Q1 star Q2, right? Form 2's reaction curve is, for example, okay, like this. That is Q2 star Q1, right? Cono solution is intersection of two reaction curve or first order condition of profit maximization of two forms. What is that? That is this one, 10, 10, right? Q1 is 10, Q2 is 10. So that is Cono equilibrium point, right? And what is collusive outcome? Collusive outcome, right, is this one. Now think about maximizing maximizing total profit when producing this one, right? So moving to this one. That is collusive outcome, 7.5. Q2 and Q1 is 7.5. This one, that is collusive outcome. Okay? And then what is competitive outcome in this graph? That is this one, right? Form and form 2's production is this one, 15, 15. That is competitive outcome, right? Competitive outcome. That is Cono outcome. That is collusive outcome. Can you understand? That is figure 12.5. Okay, I'd like to stop here.